All right, guys, what we're doing today and tomorrow, it's going to take us 2 days to go through this note sheet. We're looking at multiplication, division, and complex fractions. Now, today we're mainly going to get to the multiplication and dividing, multiplying and dividing these rational expressions. Tomorrow we will finish the dividing and then cover complex fractions. Now, when we multiply or divide, we're multiplying specifically here. The first thing we want to do is factor and then multiply straight across. So we want to factor first. But if we look at this here, can we factor any of our four spots, the two numerators or two denominators? No. They're already as simplified as it gets, so we actually don't need that second one. Because we would put 2 if we need to factor. Because we put the 2 to factor so that we can put them in factored form of each one on top and bottom and then multiply together. Now this one here, we don't need to do that because 3x squared, 2y, 4y cubed, 3x. They're all monomials or single terms. We can't factor, we can't simplify in any way, shape, or form. So we can go on and just multiply straight across. We can multiply the 3x squared and 4y cubed. We can multiply the 2y and 3x. So we'll multiply the numbers. 3 times 4 is 12. X squared, y cubed. Because x and y are not like terms, so we just multiply them together. Because whenever we have like bases multiplied together, we add the exponents. The denominator, 2 times 3 is 6. And again, when we multiply x and y, we just get xy. Any questions on this first step here? Once we get finished multiplying, we will simplify. So the first thing we have is 12 over 6. 12 over 6 will reduce to 2 over 1. 2 over 1. Now we can write the 1 in. We don't necessarily have to, because we can wait to the end to see what's left, or we can rewrite it in as 2 over 1. Now the next thing we have, guys, x squared over x. Okay, let's put that away for now, because we can do that later. X squared over x. Whenever we have like bases dividing, we would subtract the exponents. Because 2 minus 1 is 1. Now the question I normally ask is it bigger, the bigger exponent on top, or is there a bigger exponent on bottom? On top, so they stay on top. Because really what we're doing is we have 2 x's on top, 1 on bottom. So the one that's in common on top and bottom would cancel, leaving us with 1 on top. Y cubed over y to the first, 3 minus 2 is, 2. And since it's bigger on top, it stays on top. We just removed 1 from top and bottom. The denominator's simplified. On top we have y squared. So this here, we can consider the final answer. 2x y squared over 1. But do we have to write 1 on bottom? No. So this is the same as 2x y squared. These are the same. If the numerator was left as 1, we have to leave it. Because if this had been the opposite, 1 over 2x y squared, this here is not the same as 2x y squared. These are not the same. Because if there's 1 left on top, it has to stay. If the 1's left on bottom, we don't have to write it in. Questions on this here? Let's look at the next one. X minus 5 times 7 over x cubed minus 5x squared. What's the denominator of x minus 5? 1. If there's not a denominator, it's understood to be 1. Now for this one here, will any of our expressions on top and bottom of these fractions simplify or factor? Yeah. The x minus 5 doesn't, 1 doesn't, 7 doesn't. But if we look at x cubed minus 5x squared, Is there a greatest common factor? X squared, that we can factor out of both terms. And whenever we do multiplication division, we want to factor. Okay, so we want to factor top and bottom first. Unlike addition and subtraction, we want to factor the denominators and then go from there. Here, if we factor the x squared out of x cubed, we're left with x. If we factor x squared out of 5x squared, we're left with -5. Any questions on this so far? Now, the next thing we can do is multiply these together. If there are monomials, if there are single terms that we've factored out, thank you, we want to put those in front, multiplied together in front. So on top, the only term that's outside the parentheses is the 7. So it'll be out front multiplied by our x minus 5. So whatever terms that are out in front of the parentheses, we'll move them to the front and multiply those together. And then have our parentheses following. Because the number in front of our x minus 5 in the parentheses was 1, so it's going to be 7 times 1. Now, part of the reason we don't multiply is because if we're going to factor or simplify, we kind of need it in factored form. I could multiply it out and say 7 times x is 7x minus 7 times 5 is 35. But if we want to simplify with something our x minus 5, well, this needs to be in factored form, yes? So we'd have to factor out the 7, giving us back to 7 times x minus 5. So with multiplication, if we did the distributive property, we multiply through, we'd have to undo it to see if anything is in common. So this is part of the reason why we don't distribute with multiplication. We just write the parentheses times each other, or our factor numbers, the numbers out front. The denominator, 1 times x squared times x minus 5 is just x squared times x minus 5. Is there anything in common on top and bottom? So they will cancel, leaving us with 7 over x squared. Any questions over any of this here? We ready for the next one? Multiply x plus 2 squared over 6x squared by 3x over x squared minus 4. Now looking at these here, 3x and 6x squared, those two are as simplified as it gets. One of the reasons we know those are simplified as it gets because they're just a term. We don't have anything added or subtracted. We don't have two terms. So they are as simplified as it gets. Now the x plus 2 squared is factored. X plus 2 squared is the same as saying x plus 2 times x plus 2. It's just multiplied by itself. So we could leave it as x squared plus 2, just a single term, or we could write it as two terms. Sometimes it's easier to write it as two terms so we can see what the two terms are, especially when we start simplifying. Now the last thing we have is the x squared minus 4. Yes. X squared minus 4 is factorable. So we have two terms being subtracted. Now the question is, are these two terms perfect squares? Is there something multiplied by themselves that will give us each term? Well, yes, x squared is x and x. 4 is 2 and 2. So that tells us that this is a difference of perfect squares. Our signs are going to be opposite. Our factors for x squared are x and x, and 4 is 2 and 2. Because the numbers we put into both of those will be the factors, the perfect square factors of x squared and 4. So we have x and x, 2 and 2. Any questions on this here? At this point here, we can multiply these together. So on top, we would have the 3x going first, then our x plus 2 times x plus 2. In the denominator, we'd have 6x squared. Then we'd have x plus 2 and x minus 2. Nice. Any questions on any of this here? Now we need to see what simplifies on top and bottom. X plus 2 and x plus 2. We have that in common on top and bottom. And really simplifying sets of parentheses are the easiest ones to simplify because which ones look the exact same? They will cancel each other out. Now since there's no other sets of parentheses that are the same, we know that we'll still have x plus 2 on top and x minus 2 on bottom. So we'll still have those. 3 over 6 is 1 over 2. 3 over 6 is the same as 1/2. So those simplify. Now we also have x over x squared. The one on top is really x to the first. We don't normally write that in. Like bases, we subtract the exponents. 2 minus 1 is 1. And is it bigger on top or bottom? So it stays on bottom. Now this here would be the final answer. Now we could write it a little bit nicer if we wanted, because we don't necessarily need the multiplication of 1 here on top. It can just be x plus 2. The denominator would be 2 times x times x minus 2. These are the same answer, but one of them looks a little bit nicer than the other because we don't have the unnecessary spaces and we don't have that multiplication of 1 with the unnecessarily big space between it. Questions on any of this here? We ready for the next one? Now, when factoring, one of the biggest things I will say is I would always look for greatest common factor first. Because if we can factor out a greatest common factor, it's going to make it easier to factor from there if it does factor. Now, we look at these here, 3x plus 2. There's 2 terms. The degree is 1. The biggest exponent attached to a variable is 1. So we can't factor with 2 sets of parentheses. There is no greatest common factor. So 3x plus 2 is as simplified as it gets. The denominator of 2x minus 1. There's not a number that goes into both 2x and 1 other than 1. So that's as simplified as it gets. Our other denominator, 3x plus 2. Well, that's as simplified as it gets. Now the last one we have, negative 4x plus 8. Is there a greatest common factor between these two terms? 4. Now I would want to put the x term in front. If I factor 4 out of 8x, we get, because 8 divided by 4 would be 2, and we have x minus, because our next term is the negative 4. We didn't do anything with the sign, so it's still going to be negative. 4 divided by 4 is 1. Now that we have all 4 factored, we can multiply straight across. So in the numerator, we would have 4 times 3x plus 2 times 2x minus 1. In the denominator, we'll have 2x minus 1 times 3x plus 2. Is there anything in common on top and bottom? 2x minus 1 and 2x minus 1. And we also have 3x plus 2 and 3x plus 2 on top and bottom. So what's the only thing left? And since it's on top, we just have 4 over 1 or just 4. If the 4 had been on bottom, we would have had 1/4. Any questions on any of this here? Be ready for the next one. Now this one here, we are going to need to factor all four expressions. Both numerators, both denominators, the tops of both of these fractions and the bottom of both of these fractions are going to need to be factored. And whenever we have multiple things that we need to factor, I would pick whichever one I can see the factors of first, or easiest to go to first. And out of these four, I think x squared plus 6x plus 5 is probably going to be the easier one to factor. And I would look at this here, x squared, 6x, and 5. Is there a term or number we can pull out of all three? No. So we'll do our two sets of parentheses. Once we do that, we look for the sign. The third term tells us the sign that will go into each parentheses. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here it's positive, so the signs are the same and they're both plus. So we have plus and plus. Now we look at the factors of the first and third term. Normally we stick with the first term, but really we can pick whichever one has the least number of factors. So if one of them only has a single set of factors, we could do it first. X squared is x and x. Factors of 5, our third term, are 1 and 5. Because those x and x are the only factors of x squared. 1 and 5 are the only factors of 5. So we get these here. Now we can check to make sure that these work. X times 5 is positive 5x. 1 times x is plus x, which does indeed give us a middle term of 6x. So those are the correct factors. Now again, the reason I say it's good to find one of the terms that we can factor the easiest is because we want something to match. If we're going to simplify, something on top needs to match either x plus 1 or x plus 5. So that gives us an idea of what some of the factors in the numerators could be. So we can also do the x, so 4x squared, or you wanting one at the top? 4x squared minus 8x plus 3. We can do it also, because that again will help us see the sum of the factors for the others' numerators. Now, is there a term or number that will go into 4x squared, 8x, and 3? No. So there's no greatest common factor. So guys, we'll have our two sets of parentheses with 3 spaces. After we get this set up, we look for the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, the third term is positive, so the signs are the same and match the sign of the middle term, which is negative. So we'd have negative and negative. Now we need to find the factors of the first and third term. Well, with 4x squared, we'll have x and x. Now the factors of 4 are 1 and 4 or 2 and 2. Do we want 1 and 4 or 2 and 2? 2 and 2. And the factors of 3 are 1 and 3. Because there's only one set of factors for 3. Guys. Possibly. Yeah, so we have one of those two factors. Now, the middle term will be different if we choose 1 and 4 or 2 and 2. Because here, 2 and 2, we need to get a middle term of negative 8. So 2 times negative 3 is negative 6x. Negative 1 times 2x is negative 2x, which gives us which is what we want. So 2 and 2 does work. If we had 1 and 4, we're either going to multiply the 4 with the 3, which would give us 12 minus 1, which is 13. Or the other way would have given us x times negative 3, which is negative 3, minus 8, I think, gives us 9, or minus 4 gives us 7. So we get different terms. Any questions on how we factor the two denominators? Now at this point here, we just need to pick one of the two numerators to go with next. So we could pick 2x squared plus 7x minus 15. We're just picking one of these two here. Now looking at, guys, 2x squared plus 7x minus 15, there's not a number that will go into all three terms, or variable, which means there is no greatest common factor. So we'll just have our two sets of parentheses. Now from here we're going to find the sign. Since the third term is negative, our signs are opposite. If the third term had been positive, the signs would have been the same and match the sign of the middle term. Since the 15 is negative, our signs are opposite. At this point here, we need to find the factors of the first and third term. Well, the first term, 2x squared, we'll have x and, then we'll have 2 and 1, yes? Now, do we want to put the 2 with the parentheses that has plus or the parentheses that has minus? Because if we're going to have something in common on top and bottom, looking at the denominators, both of them, which one has a 2x? Because we have them both here and here, yes? And what's the sign in the parentheses that have 2x? They're both negative. So if we're going to have something in common on top and bottom, the 2x should hopefully be inside a parentheses that has a negative. Now the factors of 15 are 1 and 15 or 3 and 5. Now, well, you can try 3 and 5 first. The 3 should, and the 5 with the plus. Because if we have the 3 with the negative, we now have a 2x minus 3 on top and bottom. With the x with the plus, we have x plus 5 in the first numerator and second. Now we can check this to make sure that this does work. X times negative 3 is negative 3x. 5 times 2x is plus 10x, and negative 3x plus 10x is positive 7x, which is the middle term we wanted. Now that does leave us to the last set that we need to factor, 2x squared plus x minus 1. Again, since the 1 is negative, our signs are opposite. If the sign of the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Now the factors of the first and third term are what we are looking for next. So guys, up here, focus up here. Thank you. Factors of 2x squared. We know we'll have x and x. And the factors of 2 are 2 and 1. Where do we want to put the 2? With the plus or with the minus? Minus, because again, 2x, if we need something to simplify, it'd be nice if it is with the minus. And the factors of 1 are 1 and 1. And again, we can check this here to make sure this works. X times negative 1 is negative x. Positive 1 times positive 2x is plus 2x. And negative x plus 2x is x. Positive x is the middle term we wanted. Any questions on how we multiplied, or not multiplied, but factored either the numerators or either of the denominators? Now at this point here, we can just multiply these together. So we'd say x plus 5 times 2x minus 3 times x plus 1 times 2x minus 1. And this is over 2x minus 1 times 2x minus 3 times x plus 1 times x plus 5. If we're just multiplying these together, is there anything in common on top and bottom? X plus 5 and x plus 5. 2x minus 1, the 2x minus 3s. X plus 1s, which gives us guys. Guys. Any questions on any of this here? Because again, since everything did simplify in the numerator and denominator, we are left with 1. Because anything divided by itself is 1. Any other questions on this here? Let's look at this next one. This here, we have x squared minus 16 over x squared times x squared minus 4x over x squared minus x minus 12. Out of all these here, the x squared is as simplified as it gets because it is a single term. Now we will need to factor the other 3. Which one do we want to factor first? X squared minus 16. We have 2 terms. Are both of them perfect squares? X is x and x, and 16 is, what times itself is 16? 4 times 4 is. So this here is a difference of perfect squares. Difference of perfect squares will have plus and minus. X and x will be for x squared, and our 16 is 4 and 4. So the numbers we put in there are the perfect squares, what we multiply to get x squared, and what we multiply together to get 16. So x squared minus 4x. So x squared is x and x, yes? What times itself is 4x? Well, 2 and 2 gives us 4. But the x does not squared. It's not multiplied by itself. But is there a greatest common factor between x squared and 4x? So we can factor it out. If I take an x away from x squared, we have x minus, and if we take an x away from 4x, we have 4. Now that leaves us with x squared minus x minus 12. Since there's not a greatest common factor between x squared, x, and 12, we'll use our 2 sets of parentheses. Now we can look at the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So we have positive and minus. Factors of x squared are x and x. Those are the only factors. Now the factors of 12 are 1 and 12 or 4 and 3. Now if we're looking at the numerators, it doesn't really help us too much because we do have x plus 4 and we do have x minus 3. So that really doesn't give us a hint. But if we want the middle term to be negative, we need the 4 to be negative and the 3 to be positive. Questions on this here so far? Now we can check this here to make sure this does work. X times negative 4 is negative 4x. 3 times x is plus, which does give us a middle term of negative x, which is what we wanted. At this point here, we can multiply the numerators together. Since x is by itself, it's outside parentheses, we'd put it first. So we have x times x plus 4 times x minus 4 times x minus 4. The denominator will have x squared times x plus 3 times x minus 4. Now at this point here, we need to see what do we have in common on top and bottom. X minus 4 will cancel out. Do we have any other sets of parentheses in common on top and bottom? So we can fill those into our answer. So we have x plus 4 times x minus 4 on top. And on bottom we have x plus 3. Do we have anything else in common on top and bottom? We have our x over x squared. If we have like bases being subtracted, we subtract the exponents. So 2 minus 1 is? And it was bigger on bottom, so it stays on bottom. So our final answer is x plus 4 times x minus 4, all over x times x plus 3. Any other questions over any of this here? Are you ready for the next one? Let's look at this one here. So again, we need to factor first before we do anything else. Now looking at these three guys, the y plus 5 in the denominator of our second expression is as simplified as it gets, because y and 5 does not have a greatest common factor. And since y is to the first power, that is as simplified as it gets. Now we will need to factor the other three. Which one do we want to factor next? y2 minus 9, y squared minus 9. So, y squared minus 9, we have two terms. Is there a greatest common factor between y squared and 9? No. Is y squared a perfect square? Well, 9 is 3 and 3. Y is y and y. So it is a difference of perfect squares, giving us plus 3 and y minus 3. We could have written it as y minus 3 times y plus 3. That would have been the exact same thing. Now we need to factor the two numerators. If we look at y squared plus 3y, is there a greatest common factor between those two terms? Y. And if we factor it out, y factored out of y squared is y, plus y factored out of 3y is 3. And the last one, y squared plus 10y plus 25. There's not a greatest common factor between these three terms. The signs would be the same, since the third term is positive. Signs are the same and match the sign of the middle term. Factors of y squared are y and y. Factors of 25 are 1 and 25 or 5 and 5. We would want 5 and 5. Now, when we multiply them together, we've been rewriting it out. We can do that, or we can connect them, because it's just merging everything together. And what's in common on top and bottom? Y plus 3 and y plus 3, and we have one y plus 5 on top and bottom that cancel, leaving us with y times y plus 5 all over y minus 3. And that's it. Any other questions over any of this here? There's one, we're going to look at least this one here. And this is our dividing. Now the main difference between division and multiplication is the first step. Keep, change, flip. When we divide two rational expressions, we keep the first one the same. We change it from division to multiplication and flip the second rational expression. So we keep the first one the same, 7x cubed over z. We change it from division to multiplication, and we flip the second rational expression to 3 over 5z cubed. And this here, no matter which rational expressions we're dividing, I would do this first. Because once we have it changed from division to multiplication, we can treat it like a multiplication problem. So here we'd multiply straight across. So we multiply the 7x cubed in 3. Well, 3 times 7 is 21, x to the third. We would do the same thing with the denominators. Well, there's no number to multiply 5 with, so it stays 5. Z times z cubed is z to the fourth. Because whenever we multiply like bases, we add the exponents. 21 over 5 doesn't reduce. X and Z are not like terms. So that's it. Any questions over this here? This here is the last one we'll look at for today. Now again, there is something that we can factor, guys. Let's focus up here. Because looking at these three here, the x squared minus 9 will factor. There's not a greatest common factor, but x squared is a perfect square. We have x and x. 9 is a perfect square. It is 3 and 3. But before we factor anything, the first thing I suggest doing is to keep the first one the same. Change it from division to multiplication and flip the second expression. I would change it from division to multiplication, keep, change, flip. And once we finish doing that, then we can factor. Now the denominator is going to stay x plus 4. Our second fraction is going to stay x plus 4 over x minus 3. Those are as simplified as they get. We can't factor. But x squared minus 9 will factor. It is a difference of perfect squares, so our signs would be opposite. X squared would be x and x. 9 is 3 and 3. If we multiply these together, the x minus 3 will cancel with the x minus 3. X plus 4 and x plus 4 will cancel, leaving us with over 1, which is just the same as plus 3. Either one of these will work. We'll normally just write it as x plus 3 because the division of 1 we don't have to write back in. So this here is where we're going to stop for today. We will finish these note sheets up tomorrow.